In this video, we will look over example 2 from the 4.2 lecture notes. So again, how about your PDF? And in this problem, we're given a sample of n equals 75. That is new information. In the past, we were just talking about a single x, a single test score. Now we're talking about a sample where we have more than one x. In this problem, how many x's? We have 75 of them. Okay, that's key because now we're going to be talking about x bar instead of x. So they ask us to find the probability of a sample mean being greater than 229, given the mean of the x is 228 and the standard deviation is 6.1. Okay, so how do we know this is different? Because now we're asked to find the probability that a sample mean is greater. Okay, sample mean is x bar. In the previous problems, we were talking about x. In other words, in the previous problems, I could have asked you to tell me the probability that x, a single test score, was greater than 80. Here I'm asking you to find the probability that the test score, the mean of the test scores, the x bar, is greater than 80. Okay? Only one thing changes, so just keep that in mind as we go through it. But starting out, I always write down the solution, okay? And I write down what we were given. We were given n equals 75 as our sample size. The mean, or mu, equals 228. That is the mean of the population. The sample mean is x bar. Do not get those confused. That's a common error, okay? Standard deviation is 6.5, and we're told to find the probability that x bar is greater than 229. So x bar goes with 229, mu goes with 228. Very important, okay? Again, what is new here? We're talking about x bar, okay? Talking about x bar instead of x. And we have to remember, in the past, the z equaled x bar minus mu over sigma. There's only one thing that changes when we talk about x bar, and that is the standard deviation. If we're talking about x bar instead of x, we have to take our original standard deviation and divide it by square root of n. Why? Because the standard deviation of our x bars is the standard deviation of our x's divided by square root of n. In general, this is all that changes. If you're talking about x bar, that's all that changes. So basically in your calculator, when you enter the standard deviation, you will take the standard deviation that's given and divide it by square root of n. Okay? Remember, standard deviation for z is equal to 1. For x, it's whatever is given, and for x bar, it's whatever is given for x divided by the square root of n. Okay? Let's say that again because that's very important. Standard deviation for z is 1. Standard deviation for x is whatever is given, and this problem is 6.1. Standard deviation for x bar is 6.1 divided by the square root of your sample size, which was n. Okay? So let me kind of go out right here and show you where I have that written. So in this problem, we were given x bar and asked to find a probability. Remember, when you're given x, z, or now x bar, you use normal CDF. Okay? So second bar is normal CDF, the given mean. Okay? I'm sorry, not the given mean, the left boundary. I apologize. I need to go back and show you that picture. Okay, we're not ready for the mean yet. Here's the picture. We're trying to find the probability that x bar is greater than 229. So we need to know our left boundary, our right boundary, then the mean and the standard deviation. Okay, just going back, this is all old stuff. The only difference is when we talk about x bar, we have to have one additional step. So in this problem, we're going to draw our picture. X bar greater than 229, greater than points to the right. So that means we start at 229 and go to the right forever. So putting my finger on our two boundaries, my left boundary is 229, my right boundary is infinity, but we tell the calculator 9999. That's old information from 4.1, but that's where it comes from. Left boundary, right boundary. So second bar is norm CDF. Left boundary was 229, right boundary was 9999. The mean was given up here, 228, just to show you again. Standard deviation was 6.1, but because we are talking about x bar, we have to divide it by the square root of the sample size, or n. Put that in your calculator, and you will get 0.0778. Okay? That is the probability or the area under the curve to the right of this z value. Same thing either way. Okay? Next, they ask us if this is unusual. It is not unusual. Why? Because it's less than 2. In other words, that z, that's a z value. It's the number of standard deviations away from the mean. If it's less than 2, it's not unusual. Okay. One last comment. Please be careful how you enter this in your calculator. So let me just show you how I'm going to do it. Try to make sure you can visually see everything. You may have to bear with me, and I'll just display it clearly at the end. But I'm going to second vars, norm CDF again. Why? Because I was given x, x bar, or z, and asked to find the probability. Okay? And I enter my left boundary, 229. Right boundary, infinity, or 9999. My mean was given as 228. And again, I'll show this all clearly in a minute. Here's what I want you to focus on. Standard deviation. You want to put in parentheses 6.1 divided by square root of 75, close parentheses. Hopefully everybody can see that. That is so important. You must put parentheses around it, and don't forget to put your divided by in there. A lot of people forget that. I've forgotten it before. It's an easy thing to forget. And there is our answer. So again, just to focus in on that part of the screen. Okay. Now, let's move on to example 3. Actually, I'm going to put that in a separate video. I think it'd be easier to break up.